In this example, given that f of x equals the square root of x and g of x equals the square root of 4 minus x, we're asked to find f compose g of x as well as its domain. Let's begin by writing down the definition of f compose g of x. We know that f compose g of x can also be written as f as a function of g of x. So let's start out by writing what g of x is. G of x equals the square root of 4 minus x. Now, we're looking for f as a function of g of x, which means in f, wherever we see x, we have to plug in what g of x is. So f of g of x will equal the square root of the square root of 4 minus x. So in this case, let's replace these square roots with the exponent 1/2. So we'll get 4 minus x to the exponent 1/2. That takes care of this inside square root. Now I have to take all of this to the power of a half again. But we have the same base to the exponent of a half, all again to the power of another half. So I can multiply these two exponents together, and we'll get 4 minus x to the 1/4. Or we can call it the fourth root of 4 minus x. So now we need to figure out how we're going to get this domain. Now the rule is you cannot take the root of a number which is less than 0. So therefore, using that logic, 4 minus x must be greater than or equal to 0. So let's solve for what x needs to be in this case. We get negative x must be greater than or equal to negative 4. Now I'm going to multiply both sides by negative 1, but in doing so I must flip the inequality. So this is what I'll get. X must be less than or equal to 4. And that appears to be the only restriction here. So I'm going to write down what the domain is. The domain. X is such that x is less than or equal to 4. And on this interval, x exists for the set of all real numbers. Or, in interval notation, I can write it like this. X will go from negative infinity to 4 inclusive.